Good day. Welcome to another session of our math tutorial. Today, we'll be looking at probability theory in statistics. If I take this particular pen and I flip, what are the chances that it lands on head or a tail? You might have noticed that we can't say for sure that we are going to get a head or a tail. That's we are not sure as to whether the outcome will be head or a tail. But we all know that the possible outcome, if I flip this particular coin, will be a head or a tail. This particular concept or this particular scenario leads us to a concept in mathematics of which statistics to be specific is probability theory. Now, probability theory is basically the likelihood of an event occurring, and it helps us to measure how certain or uncertain an event or an outcome may be. So, if I take this particular coin, that's a particular coin to be, we have a head and a tail. And if I flip this particular coin, the outcomes, that the total outcome is either you get a head or a tail. But you can't say for sure that if you flip this particular coin, you are going to get a head or a tail. So probability helps us to find as to whether we are going to get a head or a tail. That if let's say you are interested in getting a head, the head becomes your favorable outcome. If you are also interested in getting a tail, it's also called your favorable outcome. With this, we can establish a formula for probability of which it is giving us probability of an event occurring equals the number of favorable outcomes all over the total number of possible outcomes. Now, if you take the coin and I'm interested in getting a head, which is it becomes the number of favorable outcomes that I want all over the total possible outcome of which it is what? Head and a tail. So we are going to get a total number of possible outcomes, which is 2, and the number of favorable outcomes, which is what? 1, and not the head. Although I am interested in getting a head, but in numerical terms, it is what? It is 1. So it helps us establish the formula in probability as the number of possible or number of favorable outcomes. Number of favorable outcomes all over number of possible outcomes. Number of possible outcomes. So now let's take an example. Suppose we have, let's say, a bag. Assuming we have this particular, let's say, beaker, and it contains 60 bags of ball. So this particular beaker contains 60 bags of ball. This particular beaker contains 60 balls. This particular beaker contains 60 balls. And in this particular beaker, 25 are red. 25 of the balls are red, and the rest are green balls. So this particular beaker contains 60 balls, of which out of the 60, 25 are red, and the rest are green. So in this case, we don't know the rest, which is green. Although we know that 25 of which 25 of the 60 are red. So with the help of this 25, we can or we be able to find out the number of green balls in this particular beaker. So we are going to subtract the 25 from the 60 to get our number of what? Our number of green balls. So if we subtract 25 from 60, we are going to get 35. So the number of green balls in this particular beaker will be 25. Sorry, will be 35. So if you are asked to find the probability of you picking a red ball in this particular beaker, it is basically going to be the number of favorable outcome. Now we are interested in getting a red ball, which is 25 out of the total balls, which is 60 in the beaker. So if you are interested in 25, if you are interested in picking a red ball, the probability or the chance of you getting a red ball in this beaker is going to be the number of favorable outcomes. Since we are interested or we are interested in picking a red ball, we are going to have the number of favorable outcomes to be 25 out of the total number of possible outcomes. And in this case, the total number of possible outcomes is 60 balls. So if this particular beaker is there, the number of outcome in this particular beaker is what? Is 60. So it becomes the number possible outcome to be what? 60. So 25 out of 60 then becomes 25 out of 60 then becomes the probability of you picking a red ball in this particular beaker, which is 5 over 12. 5 over 12. So if you also want to find the number of you or the probability of you picking a green ball, it is also going to be, so this is probability of you getting a red ball. So probability of you getting a green ball will be 35 out of the total number of possible outcomes, which is 60, and it gives us 7 out of 12. 7 out of 12. So if you want to find the probability of any given set, it is the number of favorable outcomes all over the number of possible outcomes. First of all, we use the coin as an example. So if, let's say, I flip a coin, the probability of me getting a head is 1 out of the possible outcome, number of possible outcomes from the coin, which is the possible outcomes is 1 and 2. So the probability of me getting a head is going to be, we have only one head here. So definitely the number of favorable outcome is what? Is 1. So it's going to be 1 out of the total number of possible outcomes, which is 1 and 2. That's the head and the tail. So we are going to get 1 out of 2, which is equal to 0.5 or 50%. So if you flip a particular coin and you want to know the probability of you getting a head or the chance of you getting a head, it is 0.5 or 1 out of 2. Now let's look at approaches to probability. We have 3 approaches to probability. That's classical probability concept, relative frequency concept, subjective probability concept. So let's first look at the classical probability concept. This particular concept is based on the assumption that all outcomes are equally likely to occur. So let's assume we have this particular coin. So a coin, that's a head and a tail, and we flip this particular coin. We know that these two outcomes, that's the head and the tail, they are all likely to occur. We don't have a situation whereby the head is having an upper hand than the tail, or the tail is having an upper hand than the head. They all have equal likely events, or they are all equally likely to occur. So let's take a die, a 6-sided die. So if you take a 6-sided die and you roll, the outcome or the sample space is 1, 2, 3, 4, 5, and 6. So these are the possible outcomes if you roll a die. That's a 6-sided die. The 1, 2, 3, 4, 5, 6, they are all likely to occur. That's the outcome. They are all likely to occur. So if you roll a die, you can either get a 1, 2, 3, 4, 5, or 6. They are all likely to occur. None of the numbers here is having an upper hand than the other. They all have equally likely to occur. So find the probability that, let's say we have a die and we've rolled that particular die. What is the probability that we get an odd number? So in this case, the odd number that we are getting becomes our events. So let's say we have this particular die and we are asked to find the probability that we get an odd number. So this is our sample space, which is the SS. And we have to find the probability that we get an odd number. And we know that odd number, if we are to pick odd numbers from this particular sample space, we have 1 to be an odd number, we have 3 to be an odd number, and 5 to be an odd number. Mind you, we are not going to add the 1, 2, 3, 1, 3, 5 and divide it by the total number of the possible outcomes. Now we have only 3, we have the event to be odd number. The event that we are interested in is what? Is our odd numbers, and we have 1, 3, and 5. So if you are asked to find the probability that you choose an odd number from the sample space or the total possible outcomes, it is going to be the total number of odd numbers. That's the number of favorable outcomes. And we know that the favorable outcomes, if we are to get an odd number, it is 135, and it is 3 because we have 1, 2, and what, and 3. So we are going to have, if we are to choose an odd number, we are going to have 3 out of the total number of what, possible outcomes. Mind you, this 3 here is the number of favorable what, outcomes if you are to choose an odd number. And you are not going to add the 1, 2, what, sorry, 1, 3, and 5. The odd number is our event, that's the favorable outcomes. That's what we are interested in. So if you are to find the probability that we are tossing, so we are rolling this particular die and we are to get an odd number, its probability is going to be 3 out of what? Out of 6, which is 1 out of 2. It's the same as 0.5. So that's basically for classical probability concept. It is based on the assumption that all outcomes are equally possible to occur, or all outcomes are equally likely to occur. That's the classical probability concept. Now let's look at the relative frequency concept. So the relative frequency concept is also based on the assumption that how often an event occurs in repeated number of times. How often an event occurs in repeated number of times. So its formula is also given as P of events, number of frequencies, that's how the number of times the events occur, all over the total number of possible outcomes. I have this particular example that I want us to solve. So a study of 500 graduates at UDS showed that 300 of the 500 were employed in their major area of study in the university. What is the probability that a particular graduate will be employed in an area other than his major area of study? So this particular example is under relative frequency concept. It says that a study of 500 graduates at UDS. So a study of 500 graduates. So at the end of the year, 500 students graduated from the university. So we are going to have the total possible outcomes. The total possible outcomes to be what? 500 graduates. And the second one says that out of the 500 graduates at the university, 300 of them were employed. So after graduation, 300 of these particular graduates were employed in their area of what? In the area that they measured. So 300 were employed. In area of major. So this particular one, so meaning 200 graduates were not employed, or not particularly unemployed, but they were employed in an area other than, let's say, a particular student or these 200 graduates, they studied BSc accounting. Instead of them, let's say, being employed at the banking sector, they were either working in, let's say, a manufacturing organization. Although they are not unemployed, they are employed, but it is not in the area that they major. They majored in accounting, but say it's the case that they have been employed in a different sector altogether, let's say fisheries or manufacturing company. So it is not necessarily the unemployment or the area of what they are minor, or that area that they were not what majored. Okay, so we have 200 students or 200 graduates that were employed in an area other than their major. So we have 200 employed in area other than major. Now we have to find the probability. We have to find the probability that the students, that's the graduates, who were employed in area other than their major. Remember, we are not giving this particular 200 students, but with the help of you subtracting the 300 from the 500, you can be able to tell the number of graduates who were not employed in the area of their major. So if we are to find the probability that 200 were employed in an area other than their major, let's represent it by the probability of students employed in the area other than their major as let's say EM, and this one will be M, major. So we are going to have probability of students employed in area other than their major to be number of students employed in area other than their major, which is the 200, out of the total number of graduates, that's the total number of possible outcomes, that's the total number of graduates that graduated in that particular year to be what? 500, which gives us 2 out of what? Out of 5. So the probability of students who were employed in an area other than their major becomes what? 2 out of 5. Now, the 200 students not necessarily are unemployed, but they are employed, all right, but not in the area that what they went to school what, to study or to major in. Let's look at the last approach, which is the subjective probability concept. This particular concept or this particular approach is based on the assumption on personal experience or judgment. So let's say, what's the probability of Ghana winning the upcoming World Cup? This particular scenario is under subjective. It is based on personal experience or judgment, either based on past experience because of, let's say, taking Ghana going for the World Cup, for instance. We are saying, let's say, that Ghana will not be able to win this particular World Cup because of their past results, their performance in their recent or their past matches that they've been playing with other teams. So with this, it is under the subjective probability concept that's based on personal experiences or judgments. I hope this particular concept or this particular approach is not that difficult. Thank you for staying with us. See you in another video.